every angle 90 degree. Square also has angle 90 degree. Only difference with the square is here opposite sides are equal, but that sides which are side by side, they are also equal. That's the only difference. Otherwise, this is pretty much like a rectangle. Yeah. So if we know the area of a rectangle is length times width, since we saw the area of rectangle is length times width, here also we can say the same thing. Area of a square is length times width, but my width is same as length. That is how area of a square becomes length square. So or length into length, because all the sides are same, right? So you cannot differentiate length and width. They are same. So as long as you remember the first formula of area of a rectangle as length into width, you can apply the same thing here. As long as you remember the property of the square that all the sides are same. What happens only you want to make a ponytail? Don't do that. Stay focused, okay? What happens is when I see everybody doing something else, it gets me distracted, and then you will see I start cracking dad jokes. So stay focused, okay? Here, as long as you know the area of a rectangle, sides of the square are all the same. So then you treat it like a rectangle, length times width. Your width is also same as length, so length times length. That's the area of a square. Everybody understood?
Yes, sir.
So now let's look at one more interesting thing. So far we have learned how to find out the area of a rectangle, perimeter of a rectangle, area of a square, perimeter of a square. And good thing is we have not tried to memorize the formula for perimeter of any shape so far, because we just know the property. We use the property to find it out. Okay? When it comes to rectangle, a square, we know that okay, all the sides are same. So my perimeter is just the length of the boundary. So all the sides are same. Length plus length plus length plus length. 4 times length. Done. I don't remember this formula. If I have to find out the perimeter of a rectangle, I know the opposite sides are same. So length, if this is length, this is also length. This is width, this is also width. So length plus length, 2 times width. That's what we are adding. We are just knowing the property and applying that understanding to find out the perimeter of a rectangle and square. Now, let's look at something interesting. This is a triangle.
Yes.
Anybody?
Right.
Right angle triangle? Anybody who doesn't believe that this is a triangle? Akshara, tell me.
It's a right triangle.
Yeah. Yeah. Aditi, do you disagree that this is a triangle?
Yes, because it kind of looks like a scaly to me.
It doesn't matter. I'm not really interested in knowing what type of triangle. I'm saying this is just a triangle. As long as you believe me, I'm fine. Yeah? Salini? Agree?
I say it's a right triangle
Okay.
and also a scallion triangle.
Scallion. Yeah, maybe. Yeah. Yeah, Mandeep.
Everything that looks like that is a triangle.
Right angle triangle. Yeah, it is a right angle triangle. Yeah.
What's the time?
What's the time?
What?
We have a lot of time. We have 40 more minutes. Don't worry about it. I snatched your notebook and this thing. Now next time if I see anybody doing anything, any exercise or any stretching, I will apply Hindu balm. If I see you talking more, I will find out sellotape and put it here. Okay? Alright.
How are you going to do that if we're literally in the meeting? You can't put it on your face.
So I can mute for the kids on the meeting. I can mute you on the screen. I have that.
You can mute us on the screen and we are not allowed to turn our mute on.
Okay. So that is out of syllabus. Hold it there. Hold it there. Because if we go debating about it, we will not study. Okay. Shh. Everybody here. Everybody here. Everybody here. You. Do you want me to go on? No. Stop there. Now we are looking at a triangle. Okay. That was a simple stupid question to you all. Say, okay, does it look like a triangle? The simple answer would have been yes. Now, I'm saying this is a right angle triangle, okay? I don't know how to find out the area of the triangle or right angle triangle. What did I do? I have drawn a parallel line parallel to this one here, and again from here I have drawn another parallel line to this one. Now this became my rectangle. Yeah, this became like my rectangle. And now if you see carefully, you see two triangles actually. Yeah, one with the vertical lines, other with the horizontal lines, and both are same. So basically, this triangle area looks to be half of this area because this triangle are looking same. I've just drawn a parallel line. Yeah, Mandeep?
I remember that you fold a tissue paper
Yeah.
into a triangle.
Correct. So same thing. I had a triangle. I have drawn parallel line both the sides and made it look like a rectangle. What I'm trying to derive here or tell you guys is that area of this triangle is half of the area of the rectangle actually. Yeah. So area of this triangle, if I have to say, will be equal to half of the area of the rectangle. If this was length and this was width, it will be length times width. Half of length into width. Or in case of triangle, we call this as a base, we call this as a height. So area of a triangle becomes half into length. Instead of length, I am calling this as a base. So I will call it B, and this instead of width, I am calling this a height. So area of a triangle is half into base into height. Yes, I agree.
Like the lines, like square lines in that picture. It kind of looks like while you're walking to a secret portal and all this stuff. And this is like the kind of art I want in my art class. But I think we're not talking about art. We're talking about math.
Okay, so keep it simple. Okay, let's not worry about it. What I'm trying to say is, I had a triangle. What did I do was, I tried blowing it up to make it double, and that looked like a rectangle. That means this triangle alone is half of the overall rectangle that you see on the board. So that is how area of this triangle is looking to be half of this rectangle, and this became half of the rectangle. This is my area of the rectangle, and the area of triangle became half of that. So that is how I'm just telling you guys how to understand this formula, because when you guys go to 7th or 8th grade, I will also prove it mathematically. Right now I'm just giving you a pictorial view of this. When you guys go to 7th or 8th grade, I will break this down in math form. That is when we'll talk about or learn about something called congruence, and we'll use those concepts for proving that. Right now I don't want you guys to get overwhelmed by the theorem of congruence. That will be just too much. So let's just look at it like a picture, and it helps you remember this formula. Yeah.
Is that for 7th and 8th grade?
You have to go 3rd grade, 4th grade, 5th grade, then come 7th and 8th. Don't worry about it right now. Right now you have to only learn. Okay, everybody here, no parallel talks. If I have a triangle and this is my base, this is my height, then the area of the triangle would be half into base into height. Okay, and you can use this as a base. What will happen is, if let's say if your triangle is like this, if this is not a right angle triangle, then this is your base. Formula remains the same. This is your base. You have to find out the height, meaning you have to find out this height from the top, and this will be area, same. Area will be equal to half into this base multiplied by height. Okay, has everybody understood this? Is everybody able to follow what I'm saying? Okay.
Yes. Yes.
Okay, cool.
Yes.
Now let's look at something more interesting. Nandu Baba? No? Okay.
How much more time do we have?
Hmm? Why to worry about that? See, if you stay focused, if you keep learning, time will just fly. You will not even realize. I'm busy teaching you guys. I don't realize. When I see kids from other groups joining, that is when I realize the time is over. So if you are engaged, if you are busy, what we are doing, if you are trying to understand that, you will not realize the time. If you are just waiting, okay, 5 more minutes, 10 more minutes, 20 more minutes, it will look really long. Trust me. Whenever you are watching TV, do you see time? No, because you are so engaged, you are involved, you are enjoying it. You don't feel the time. If you stay engaged, if you keep learning, time will not even be a matter of concern. It will just disappear. Oh, you say, oh, wow, it's got over. So stay engaged, keep learning. That's what we are here for. Now we looked at rectangle, we looked at square, we looked at triangle. We learned one more shape today, that is called rhombus. Rhombus. Diamond, gold, silver. We are not learning about that. We know this. I mean, this is called diamond also, but mathematically this is called rhombus. Okay. Okay. Hold it there. If this is rhombus, then what is that you guys recall as a property? Yeah, Chara.
It's just nothing. It's just nothing.
What is that?
It's nothing.
Okay, yeah, let's see what Sammy has to say. Yes, Sammy.
Oh, it's kind of like a square. It's basically like a square, but like you said, it's squeezed in.
Squeeze the square. Yeah.
It has 4 angles.
Right. So what happens is you had a square. You had a square. What did you do? You picked up two vertices and you squeezed them. And when you squeezed them, it became thinner and longer. Right? Let's see. You see me as a fat guy. You squeeze me from both the sides. What will happen? I will become taller. I hope there's a machine which presses me on the sides and I become taller. That'll be fun, right? So that's what happened with this guy. So all the sides remain the same. The length of all the sides remained the same. What happened was the angles changed. In case of a square, every angle was 90 degree. Every angle was 90 degree. Now what happened? This became more than 90 degree. This is also more than 90 degree. That's what it looks like. And this became less than 90 degree. Less than 90 degree. Okay? These two are less than 90 degree. Okay? So that's a rhombus. Now, one more thing here. We have to find out the area of a rhombus. Let's see what happens. Whoever needs Zandu one, let me know quickly. I can go and get one. I have Zandu one at home. If you want, I can get one. Okay. Anyone? Okay. So here, if this is my rhombus, okay. How do you find the area of the rhombus? Yes, Salni, you're saying something.
It's just before the question, like the other question you said before, I forgot to keep it away.
That's okay. That's fine.
But still, I have to say it.
Okay. So, Gautam, are you with me so far?
I'm with you.
Okay. So, if I have a rhombus here. If I have a rhombus here, does anybody know how to find out the area of a rhombus? Tell me.
Cut the middle and then find the area of both perimeters. Both triangles.
Okay. Anybody can give me any clue. Yeah, Aditi. Keep it short. Yeah.
Like if we see some size, if A is gonna be like if A and that down C, it's gonna be like 6, and then it's
Okay. Hold it there. Let's make sure we have how much time. We have only 7 more minutes. Okay. No fighting, please. No fight. No, Nehit, Satvik, stay a little away. We don't have time. Here, the only clue I want to give you guys is Arnav, no singing right now in the class. Okay, okay. Everybody stays quiet. Everybody stays quiet. Yeah. See here, when you look at this rhombus, what do you see? What did I do? I joined the opposite vertex and that broke it into 4 triangles. This is one triangle, this is second triangle, then there is a red triangle also here.
Red.
And then we have a green. Let's see if I have a green triangle. No green triangle. Okay. Okay, another red triangle here. There are 4 triangles. When I joined the opposite corners of this rhombus, it broke it into 4 or split into 4 triangles. And interesting part is all the 4 triangles are same in size. Okay? And these corners, when I join these two, these are called diagonals. Let's say this is A to C is diagonal 1 and B to C is diagonal 2. Okay? So this is D2 and this is D1. So area of a rhombus is half multiplied by diagonal 1 multiplied by diagonal 2. Diagonal 1 to diagonal 2. Now you will say how. So that how part I would not try teaching you guys now. If I do so, same problem, same symptom. Everybody lose hair like me. So I'll teach you guys when you go to 6th or 7th grade, because that is where it has correlation with the theorems of congruence. Okay, and that will be just too much and too early for you guys. So let's not worry about that. Simple way you can look at it is when you have a rhombus and you join the opposite corners, these are called diagonals, and the diagonals split them into 4 equal triangles. Yep. Yep.
I forgot to tell you this at the first of the meeting. Sorry for joining on the other meeting.
That's okay. Don't worry about it.
I didn't know. I thought that the meeting code was different, so I just joined and I accidentally went in like a 8th grader group.
Anybody can join any meeting as long as you're able to understand. I'm fine. I don't mind. All right. So yeah, coming back to this one. Coming back to the class. So here, only thing that is going to be a takeaway is if you have a rhombus, you join the 2 opposite corners. Those lines that is joining the opposite corners are called diagonals, and the diagonals, they help you find out the area of the rhombus, which will be half into diagonal 1 to diagonal 2. How is that derived? That should not be a matter of concern now. In the next class on Saturday, we will do few sums on whatever formulas we have learned. We'll play with them. So I will give you guys some sums just to see if you are able to relate them and solve some. But even if you get stuck, don't worry about it. Next class we'll do practice, okay? We'll do some practice. We'll try solving some sums in the class. And anybody have any doubt, that will get sorted out. Yep. Yep, Sami, you're saying something?
Oh, sorry, it stayed on from
Okay, not a problem. So that brings us to the end of the class. That brings us to the end of the weekend for you guys as well. So enjoy the rest of the hours that you have for the weekend, and I'll send you guys assignment early next week. Yeah, Aditi, you're saying something. Go ahead.
You know, Halloween and Diwali come at the same time.
Yep, that's true.
I'm gonna see fireworks when you're trick-or-treating in the air. What are you going to give out for Halloween?
Okay, a lot of good questions. I don't think I was prepared with the answer. See, what happens is when I come to the class, I prepare to figure out what I'm going to teach you guys. I was not prepared for this question though.
You give us candy on Halloween.
Huh?
Candy?
Okay.
Am I very good?
Okay.
Yes.
So,
I'm gonna put this costume. I don't have it.
okay. So I will let you guys. I'll let you guys go have fun, enjoy the rest of your weekend, and you guys can drop off from the call and be ready to get some assignments by mid of week. Try solving those problems. If you get stuck, don't even bother. It's okay. Because we have not practiced some. We have just found out how to derive the formula and how to use them. We will use those more in the next class and see what is easy, what is not. Yeah?
Bye, sir.
Alright, bye bye, take care.
Bye, sir.
Bye bye, bye bye. Bye Nihan, bye Akshara, bye Shalini,
Bye, sir.
bye Sami.
Bye, sir.
Bye bye, bye bye, bye bye. Yeah, take it. Yeah. Alright.
There's a green one down there.
Okay, now we have kids from the next class joining. If